Hi guys, it's Mrs. Jackson. I just wanted to create a quick little video to show you some tips and tricks for balancing our single and double replacement reactions. These reactions are the ones that work with ions and ionic compounds, and you can see zinc sulfate here, lithium carbonate, zinc carbonate, and lithium sulfate. One of the things that students struggle with when they start balancing some of the single and double replacement is they, first of all, they think they look a little bit scary because there's so many elements and it seems like there's so much going on. And the fact that there can be elements like in this case oxygen that's just everywhere. All right, so I'm going to show you a couple of tips and tricks that will make balancing these a little bit easier for you. So go ahead and get your notes out, write down these examples so that when you start your homework you've got a couple of good examples to refer to. What we're going to do with this double replacement reaction is we're not going to balance all of the elements individually. What we're going to do is we're going to focus in on what kind of ions we have. So in this case up top I've got the zinc ion, but then I've got this sulfate. I've got SO4. You should recognize that sulfate is an ion all by itself. Normally we might see parentheses around these in an equation. But you should recognize these polyatomic ions. When I look at a double replacement reaction and I see sulfate on the left and I see that sulfate is unchanged and exists also on the right, I can treat sulfate as if it's one single thing instead of 5 separate atoms. And that's going to make our process of balancing an awful lot easier. I'm going to do the same with carbonate. I've got lithium carbonate. Lithium, there's 2 lithium atoms, but if I circle my carbonate, I only have 1 carbonate ion. The same is true on the side of the products with just a single carbonate ion. So when I look at these, okay, and I start looking at my elements, one of the tricks and tips that some students use, and I'm going to demonstrate it here, is under our arrow, we list the elements or the ions that we want to balance. So let me walk you through that on this example, and I'll show it to you in a second and third example in just a moment. What I do is I want to look at the elements or ions I have. In this case, I've got zinc, and I'm going to write it down the middle. I've got sulfate, and instead of writing it as if it is just sulfur and oxygen, I'm actually going to treat that sulfate as one thing because, like we said earlier, it's exactly the same on the left as it is on the right-hand side. The next element I come to is lithium here, and so I'm going to write lithium down the center. And then I've got my carbonate in my circle, and carbonate is a polyatomic ion that appears the same on both sides. So these are the 4 ions that I'm going to try to balance, or I'm going to look at in this equation. What we do, and there's several different ways that you can go about this. I've got the ions listed underneath the arrow. I have seen it done where the formatting is different, but the concept is the same. What we do is we simply at this point count how many of the atoms or ions are on each side. So for the zinc, I only have 1 on the left-hand side. Right there, I just have 1 zinc. Okay, for sulfate on the left-hand side, I only have 1 sulfate ion. That SO4 is 1 ion, and there's only 1 of them on the left. Lithium right here in the middle has 2 atoms of lithium, and the carbonate, there's just 1 carbonate in that circle. On the product side, I count again. Zinc has just 1 atom right here, just 1 zinc atom, and I only have 1 carbonate in the circle, so I'm going to come down here and put a 1. When I look at lithium in this compound, there's 2 atoms, right? That subscript tells me there's 2, and I only have 1 of the sulfates in my circle. So when I look at what I have written down the center of my reaction here, I can see that all of my ions are actually already balanced on each side of my equation. All right, we're going to look at another example where we're going to need to make some changes. You can do this method of writing the ions down the center and under the arrow, or you can do the back and forth comparison method, whichever one works. for you, that makes the most sense for you to use. I can use both. I prefer to do the back and forth comparison method, but this way of writing the ions under the center is an awfully good way to get started, especially if you're very visual in the way that you learn. So let's look at another example. This is another double replacement reaction, and I'm going to create a couple of circles here so that we can circle polyatomic ions when we find them. So I start to look, and I've got a manganese ion, I've got manganese nitrite, and I have my beryllium chloride. So when I look up here at my reaction, I can see that I've got nitrite, that's the NO2. So I'm going to go ahead, I'm going to put a circle around that. You can see it's in parentheses, and those parentheses are the same as the circle. So you don't have to put a circle around them. You can put parentheses if you like. The circle is just the easiest way for me to show it to you. Kind of on this in this digital format. So I'm going to treat the nitrite like it's one thing, right? So the NO2 is one ion. It's going to stick together. And I know that it sticks together because when I come to the left or the right hand side and I check my products, I already have my nitrite ready to go. All right. So again, writing our ions down the center, I check I've got manganese as one of my ions. I've got nitrite, NO2, as a different ion. I've got beryllium as a type of ion. And I've got chloride as a type of ion. Then I go through and I simply count. I've got one manganese on the left. I've got one manganese on the right. I have nitrates. I have two nitrates on the left-hand side. I also have two nitrates on the right-hand side. That subscript tells me I've got two of what's in the parentheses. So when you see that two outside parentheses, that means there are two of them. I have a single beryllium on the left, and I have a single beryllium on the right here. And then there's two chlorine on the left, and there's two chlorine on the right. So as I check this reaction, again, practicing circling our ions and counting, when I look at what I have, I'm already working with a balanced chemical equation. So let's take a look at one that we're going to have to balance. So looking at our aluminum sulfate calcium hydroxide reaction, I see that I've got some polyatomic ions. I've got a sulfate ion here. Let me shrink my circle a little bit. So I've got a sulfate ion right here. And I know that I can use my nifty little trick because the sulfate is the same on both sides. Okay. I've got sulfate on the left. Here is the sulfate on the right-hand side, right there. I also have hydroxide. So I've got hydroxides here. And I have hydroxides here. And keep in mind, our little trick of using the ions only works with replacement reactions, and that's only if they're the same on both sides. So what I want to do is I want to see what elements and ions I'm working with here. So down the center, I start counting my elements, and I count the atoms of each one. So I've got aluminum is one of my ions. Then I've got that sulfate, and I'm going to use that entire sulfate as my particle, as that ion, as we start trying to balance this. Then I've got calcium as an ion, and I've got hydroxides, the OHs, as ions. Then I simply count how many of each there are. I have two aluminum on the left. I only have one on the right. This 3 that sits outside of this circle, or outside of my parentheses, tells me that I have 3 of the sulfates. So I've got 3 sulfates on the left, and on the right hand side I only have 1. So I only have 1 sulfate as a product. I have 1 calcium here on the left hand side of my reactants, and I have 1 calcium on the side of my products right here. And the last thing I look at are the hydroxides. There are 2 OH ions on the left, and I have 3 of the OH ions on the right-hand side. So this one looks a little different than the first 2 because we have to balance these. So what I do, and there's a couple of ways you can go about it. I start with the first element in the reaction. It's usually the one at the top of the list, and I make that correction first. So I have 2 on the left-hand side, and I only have 1. So the easiest fix is to put the 2 in front. Now remember that 2 distributes to the aluminum and tells me that I've got 2 aluminum atoms, which is what I need. But the 2 will also distribute to the hydroxide. This is just like math, and when you have a coefficient in the front, it distributes to whatever's behind it. So I have 2 of everything in my chemical formula. That meant I have 2 aluminum atoms, but it also means I have twice as many hydroxides. Well, I had 3 when I started, and I put a 2 in front, and I just doubled it. So 2 times the 3 is 6, because I have 2 of those particles that have 3 hydroxides each. So now I've taken care of my aluminum. You can, at this point, choose to go to the next ion in your list, or you can try and balance the hydroxides. I'm going to move down the list just for the simple methodical process. You can choose to do either way that works or makes more sense to you. Looking at my sulfates, okay, so if I'm looking at the sulfates in the aluminum sulfate, I have 3 on the left, and I only have 1 on the right. So that's another easy fix. I'm going to put a 3 in front, so my coefficient in front is 3, and that gives me 3 of the sulfates. Remember, it distributes to what's behind it. So 3 times 1 is now 3 sulfates. But remember, this distributes to the entire formula, so that means I have also now 3 calcium. So I have to cross that out and make it 3. Okay. And now I have balanced, or I have completed distributing that 3 to the formula. My aluminum is now balanced. The sulfate is now balanced. Now I'm going to look at calcium. I now have 3 on the left because I put the 3 in front of my formula, and I have 1 on the right. So an easy fix, I put a 3 in front, and that coefficient distributes to the calcium. So 3 times the 1 calcium makes 3. But it also distributes to the whole formula. I started with 2 hydroxides, but I just tripled it by putting the 3 in front. So 3 times 2 is going to give me 6. So when I look at what I've done, I have 2 aluminum on each side, I have 3 sulfates on each side, I have 3 calcium on each side, and I have 6 hydroxides on each side. So this equation is balanced. Again, this isn't the only way to work through these, but it is a way that makes sense to a lot of students. If you were asked to write the coefficient ratio, remember there's an understood 1 in front of my aluminum. If there's a blank, it doesn't mean a 0, it means there's an understood 1. So if I asked you to give me the ratio, you would give me 1 to 3 to 2 to 3. Simply pulling those coefficients from the reaction and putting them into the ratio. 1 to 3 to 2 to 3. And that's the ratio of those compounds in this chemical formula. One last example, I'm going to show you what to do when you have water in a replacement reaction, and this will work for double and single replacement reactions. What I'm going to do with water, remember we said we can only use our trick for circling our sulfates and our hydroxides if they stay intact. So there's my sulfate is the same on each side, so that helps. But it looks like I've got hydroxide on the left, and it doesn't look like I have any hydroxides on the right. So it looks like that's a problem. What we're going to do is this. We're actually going to make the water, we're going to rewrite that formula, and we're going to rewrite it as HOH. Okay, so I'm going to rewrite this as HOH And what that allows me to do is it allows me to see that I have the hydroxide also on the right-hand side. So following the same method that we just used, down the center, I've got hydrogen is an ion. I'm just going across and counting my elements and ions. Hydrogen is 1. I have sulfate in this reaction. I've got, one moment. I think that's supposed to be barium. We're going to pretend that it is, but we're just going to write the B. I've got B, but it should be barium, or beryllium, I'm sorry. Okay, so we're going to go with BE. And then I've got OHs. Okay, so when I count them, we just simply go through what like we have before. I've got 2 hydrogens on the left. When I look at the right-hand side, this hydrogen on the left is this hydrogen on the right. So there's 1 hydrogen. I have 1 sulfate on the left. I have 1 sulfate on the left. When I come to the right, I have 3 sulfates on the right. I've got 1 B on the left. I've got 2 on the right-hand side right here. And the OHs, I have 3 OHs on the left, and I only have 1 of the OHs on the right. So if we keep that hydroxide in that circle and we separate the water into HOH, it makes balancing this an awful lot easier. So all we need to do now is work through the rest of our coefficients. So hydrogen is taken care of. I move down to sulfate, my SO4. I have 1 on the left and 3 on the right. So I'm going to put a 3 in front where the sulfate is. So that 3 gives me 3 times 1 is 3 sulfates. So that works. But very carefully, listen here. The 3 also distributes to the hydrogen. Well, I had 2 hydrogen, and I just tripled that by putting the 3. So now I don't have 2, I now have 6. Totally fine. Just have to work with it. Just keeping track of how many we have will help us get it balanced. So now I have 6 hydrogens on the left, and I only have 2 on the right. So what I can easily do, I don't want to put a 3 in front because I do need to make this a 6, but because it's a 2 coefficient and I have a 2 here, I'm just simply going to change that from a 2 into the 6 that I need. So I'm going to make this a 6, and that means I now have 6 hydrogens on the left. This 6 replaces the 2, and I now have 6 hydrogens, but because the 6 replaced the 2, I now also have 6 hydroxides. Remember, I'm multiplying that 6 times the understood 1, so the 6 just replaced the 2. So now I have 6 hydrogens on either side. I have 3 sulfates on either side. Now I can turn my attention to the B. I have 1 on the left and 2 on the right. So I'm going to put a 2 in front to double that. 2 times the 1 gives me 2 B's, but it does distribute to the OHs also. I just doubled my number of hydroxides. So 2 times 3 is 6. And now I have 6 hydrogens on both sides, 3 sulfates on both sides, 2 B on both sides, and 6 hydroxides on both sides. Okay. If you do not use this method, that is fine. For a lot of people, it helps to see it very visually before they go into the bounce back method. I bounce back and forth to balance my ions just back and forth. Put parentheses or circles around your ions, and you can use this information in a couple of different formats. Again, use these examples as you start your practice problems today. and email me if you have any questions. I will talk with you soon. Bye.